Hello everyone, thank you very much for that introduction. I have great pleasure and it's I much appreciate being able to address you on this very important topic of climate change an existential threat or not. The presentation will give a brief independent overview of the latest climate science, and it may not be what you read in the papers every day. It identifies some important differences from IPCC conclusions, unfortunately not understood in policy making. It concludes that there is no immediate threat from climate change, but there are threats resulting from associated policy making, particularly in energy security. Just aside, the ICSF mission is to disseminate objective climate science in the best national interest. We are modestly self-funded and have no vested interests. We cooperate with the Dutch-based Clintel International Group, which has over 1,100 leading scientists and professionals in over 30 countries across the globe. Logically, one begins by assessing the paleoclimate. This graph demonstrates the temperature variations in red and versus the CO2 changes in blue over the last 630 million years. The graph maybe look rather complex, but it tells you very quickly that there is not a direct correlation between CO2 and temperature. For example, at the left-hand side of the slide in the blue box, it demonstrates that CO2 in the Precambrian period, CO2 was at a level of 7,000 parts per million, 15 times that of now, while temperature was actually below that of today. And conversely, in the pink box towards the center, the temperature was above that of today with CO2 levels approximately similar to those of now. Moving forward in the Pleistocene period, over the last 450,000 years, there has been a notable change in that the temperatures have varied according to the Milkanovich cycles, which depend on the eccentricity of the orbit of the Earth around the Sun. There have been long cold periods in blue of 90 to 100,000 years, intermittently with warm periods about where we are now of 10 to 20,000 years. In the bottom graph you can see there's a plot of both the temperature and carbon dioxide levels during those times. Carbon dioxide being lower than now, 180 to 280 parts per million. But interestingly, it lagged the temperatures. You know, perhaps the moral is we are in that very small box, the sweet spot at the top right-hand corner of the upper graph. So let's enjoy the benign climate while it lasts. Moving forward from there and expanding that tiny box, we move into the Holocene period, which began about 11,700 years ago. And after what's called a Younger Dryas period, there was a major thawing and temperatures moved up, as in the blue graph on the top. And there was a climate optimum of about 8,000 years ago, where the temperature was at its warmest, the megalithic period about 5,000 years ago. And moving towards the right-hand part of the graph, there were three warming periods in the last 5,000 years. The Minoan warming, the Roman Minoan about 3000 BC, and the Roman from about 200 BC to 400 AD, and the medieval warming from about 900 to 1200 AD. After that was the Little Ice Age, and we're now at the very right-hand green bar of the current modern warming period. It's interesting to note that the three prior warming periods were not forced by CO2. The CO2, as in the bottom graph, was at quite low levels. And one can also note that the current warming is not significantly greater in scale or in a rapidity of warming than the other previous warming periods. Just to give it a little pictorially, in the medieval warming period was the time of building the great cathedrals, it you know, was a great time of civilization moving forward. After that came the Little Ice Age, which had very bad cold weather and featured things like the Black Death plague and the Irish famine in 1845. So, that kind of gives you a bit of visual as to how the climate has changed over the last 2,000 years, quite dramatically. Looking at temperature trends since 1850, and 1850 is regarded the beginning of the Industrial Revolution and when anthropogenic warming began. And, it's not all upwards. You can see that there are distinct periods of cooling from about 1870 to 1915, warming from 1915 to 45, then cooling 1945 to 78. And the big worry in 1970 was of global cooling. And thereafter was warming from 1978 onwards. So it's not all going upwards. There are natural factors at play also in the climate variability. And another point to note on this graph, particularly towards the right-hand end, the right-hand side, is the graph shows the land-based temperatures in red, the sea-based in blue, and the average in black. But you can note that the land-based temperatures are considerably, say about half a degree above the sea-based, which is very much indicating the errors that are coming in due to the urban heat island effect. Looking at more detail, since 1979 we've got satellite records of the climate temperature variations. And you can see there's very considerable pulsations, and they are due to the El Nino and La Nina, the natural events of warming and cooling from the Pacific. And you can see right at the center, the 1998 El Nino caused the highest temperature in recent years. And that of 2015-16 still remains the highest in up to now. So the planet is actually slightly cooling, believe it or not, since then. There is, amongst all of that natural variability, there is an overall upward trend of about 0.1 degrees centigrade over that 40-year period. So if continued for up to the year 2100, that would mean about 0.8 of a degree further rise between now and 2100. So that gives a very good practical rule of guide as to how the climate is actually behaving. Did the sun cause those variations? Believe it or not, back in the 1700s, the corn merchants had figured out that the number of sunspots, which determined the strength of the sun, could be used to predict corn prices. And they then started recording it, and moving forward, the very low sunspots and low sun energy was definitely the cause of the Maunder minimum and Dalton minimum, very cold periods leading into the Little Ice Age. And during the later 1900s, we enjoyed quite a solar maximum, which arguably was the cause of warming over that period. And Ronan Connolly and his associates have done a great analysis recently showing that it's possible that all the modern warming could be attributed to solar activity. But, it probably is a mix of greenhouse gas influence and natural influence. We're now coming into cycle 25 at the very end of the picture. And some say that it is actually declining in number of some sunspots and could lead to some cooling, believe it or not. So how do the IPCC models compare with reality? John Christie of the Huntsville University in Alabama has plotted all the climate models of IPCC from their fifth assessment report, AR5, in terms of the spaghetti curves that you see on the upper portion of the graph, the red being the average of all those. And at the lower part in green, he has plotted the actual climate temperatures as measured by satellites and verified by balloons and radiosondes. And it's very, very clear that the IPCC models are overheated by a factor of 2 or 3, believe it or not. Then he did the same for the AR6. This is the sixth assessment report of IPCC, which is in the process of being finalized, the final synthesis report. And again, looking at all the various models in terms of the spaghetti curves and taking the green as the moving average and the red as the linear average of all those. Again, comparing those with the actual climate temperatures, there's a big, even wider differences. So that raises big questions over the IPCC models, that they're running too hot effectively, and they need some reality checking. Looking for the moment at the physics of radiation transfer, and I'll try to keep it as simple as possible. At the top left in red is pictorially the incoming solar radiation to the Earth. And yes, some of that does warm reaches the surface, does warm the Earth itself. But this is counterbalanced by the blue part, the outgoing infrared radiation, which predominantly is in the vertical red box. And you can see that in the boxes towards the bottom of the slide is retarded or held back by the various greenhouse gases when those infrared radiation react with the natural frequency of those molecules, which creates a heat trapping effect. And the principal greenhouse gas of all is water vapor, clouds, and amongst the others are carbon dioxide and methane. Looking at more detailed and assessing what the various greenhouse gases are causing, this graph is from work done by Professor Will Happer and William van Weidengarten. And they have based really pioneering analysis on quantum mechanics, atmospheric thermodynamics, and molecular spectroscopy. And what they have shown in this, in the blue curve, the blue smooth curve, is what would be the radiation from if there was no atmosphere from the Earth. The more jagged curve underneath shows what the actual radiation is in terms of the blanketing effect of the various greenhouse gases. And you can see it, water vapor, nitrous oxide, carbon dioxide, and methane all play their part. But in their work, what they first did was taking a CO2 at zero, in other words, no presence of CO2 in the atmosphere. And that would have led to the curve as depicted in the green at the top of the vertical oval, the larger oval. Then they simulated what would happen at 400 parts per million, and that was the black curve, which is down below, and shows that there is a huge difference. The first 400 parts per million of CO2 present in the atmosphere makes a big difference, and in fact makes the planet habitable. They did further experiment then on raising that concentration to 800 parts per million, and believe it or not, it had made any difference, only 1% in terms of the radiation transfer. So in the bottom, it illustrates more clearly the declining effect of CO2 as it reaches saturation in the atmosphere. The initial 150 is the part that does the main greenhouse gas effect thereafter, and we're now in the situation where the red arrow is showing about 420 parts per million, which is showing a very declining effect of any further increases in CO2. They did the same for methane, and that led to the extraordinary result, as you can see in barely distinguishing between the green, black and red colours, that the increasing the concentration of methane has virtually no effect as a greenhouse gas because of saturation. Now, I know that yes, methane on its own is a very powerful greenhouse gas, 25, 30 times that of carbon dioxide, but in reality it makes very little difference, and that finding is of huge consequence to agriculturally based countries like Ireland and New Zealand. Happer and Weingarten then verified their models by comparing the models as in the left-hand column with the actual observations from satellites in the right-hand column for a series of locations, including at the tops the Sahara, then the Mediterranean, and then the Antarctic. And they got incredible replication of their findings, which really demonstrate the validity of their approach. And it really verifies this new method of determining the greenhouse gas effect, and has greater credibility, in fact, more accuracy than the IPCC models. This graph is very interesting, these two graphs. The one on the left shows the increasing presence of CO2 in the atmosphere as measured at the Mauna Loa laboratory in Hawaii. And yes, that is increasing since measurements began in 1953. It's now up at about 420 parts per million. The world unknowingly conducted a big experiment in 2020. Well, with the COVID lockdowns, there was a 6% global drop in CO2 emissions, but that had no effect on the atmospheric levels of CO2. And that is because the human added contribution of CO2 is very small compared to the total carbon cycle within the atmosphere. So that showed, you know, the mitigation, in fact, even at a global scale, has very little effect on climate. In fact, negligible effect. On the right-hand graph, a very interesting projection of future CO2 levels right up to the year 2100, as recently modelled by Roy Spencer. And that shows that we likely to achieve about 560 parts per million, that is doubling of pre-industrial by the year 2100. But now we can see that we're actually at 420 parts per million, we're 50% above pre-industrial. We've had only 1.1 degrees centigrade warming, and that actually determines very precisely that the climate sensitivity to doubling of CO2 cannot exceed 1.5 degrees. And then doing simple maths projecting forward, that the temperature rise from pre-industrial at 2100 cannot be more than 1.6 degrees. In other words, only about half a degree further warmer from now. And that certainly is not an emergency. Looking at sensitivity in the overall sense, IPCC in over several reports has put climate sensitivity in the range of 1.5 to 4.5 centigrade, as shown in the oval at the top of the right-hand graph. And, you know, they've not managed to reduce that much over several decades. But as I've just shown you now, we have evidence, very good empirical evidence, that climate sensitivity cannot be more than 1.5 degrees. And, you know, IPCC has also ignored the excellent work of Professor Ray Bates, which showed climate sensitivity of as low as 1 degree. And also, as you can see in the lower ovals, that are the work of Spencer and Linson. So there's very strong evidence for very low climate sensitivity, well below what IPCC is talking about. And so that overall conclusion is that the IPCC models, particularly what they call their RCP 8.5, are overheated and need major review and are questionable for use in policy making. And in the box at the bottom left, my empirical based estimates include further temperature rise of about half to 0.8 degrees by 2100, which are actually within the Paris Agreement limits, and even without any mitigation. So that does certainly indicate no climate crisis. Moving on to some other areas, global mean sea level. At the top-hand graph, the satellites are showing over the last 30 years that the average rate of rise, and it's not increasing, not accelerating, it is increasing at about 3 millimeters per year. In the lower graph, the tide gauges over the last 100 years show that sea level is increasing by about 1 to 2 millimeters per year. So if you take the satellite figure, and multiply it by 80 years up to 2100, you're talking about 25 centimeter further rise. And that certainly is not an emergency. The Pacific Islands are not disappearing, and just talking of oceans, the Great Barrier Reef has recovered and there is no ocean acidification. The Arctic is often taken as a sign of global warming. But yes, it did decline from when satellite measurements started in 1979. But over the last, towards the right of the hand of the upper graph, it has stabilized from the year about 2007 over the last 15 years. It's relatively stable, up and down, but relatively stable. And the lower graph does show that probably, the reconstruction shows that probably similar decline in the Arctic occurred back in the warm days of the 1930s. And so Al Gore's predictions are not coming true. The Arctic is still there and still doing well, and the polar bears are thriving. Looking at Greenland, despite again regular scares, the Greenland temperatures are, as determined by ice cores, similar to those of the 1880s. And it was actually warmer 5,000 years ago in the climate optimum. And the Vikings went to Greenland because it was green in about 985, and they thrived there for 400 years. So there's a different side to Greenland. And you know, another story is that some World War II aircraft which crash landed in 1942 have now been recovered from between 10 and 30 meters of snow. So the Greenland is not disappearing. The Arctic is at record cold levels. The records show, in fact, that it is at the coldest now of the last 2,000 years. And in fact, right now, it's about 4.4 degrees below normal. And you hear some scare stories of huge losses a couple of years ago, talking of 3 trillion tons of ice being lost in 25 years. But the media failed to add that that was only 0.1% of the total mass. So the Antarctic is not disappearing either. Glaciers often feature in the headlines, melting, but you know, that is a natural process. They were formed up to 1,000 years ago by the cooling of the climate, and are now simply melting because of the warmer climate. And the very interesting thing, as shown in the photograph, that after that melting, you actually rediscover old vegetation and artifacts dating from before the glaciers. So there's a very interesting example there of the climate reverting to what it had been hundreds or 1,000 years ago. Weather extremes, the media love to show us and tell us that things are really bad. But you know, a detailed objective analysis often shows that whatever it is not unprecedented. It happened 30, 40, maybe 100 years ago. And actually, IPC itself, in its technical summary, states that there's no increase in all of those boxes marked no, only in those boxes highlighted in yellow, which are heat waves, heavy precipitation, some forms of drought, and fire weather. Yes, statistically, there appears to be some kind of increase. So it's not quite what you think. Yes, there are some events that are becoming certainly more apparent right across the world. And you know, black swan events will occur when logically they should not be, but we have experienced them and are experiencing them. And we need to be prepared for these. There's no doubt about that. We need to adapt to our changing climate. You know, heat waves, actually nothing new. Again, this plot of US heat waves shows that there were more heat wave and hot days back in the 1930s, in the Dust Bowl days. And you know, there are records of heat waves in the UK back in the 1600s and the 1800s, and the Irish records of 1876 and 1887 still stand, believe it or not, despite the few decent days we had of summer weather. But what they don't tell you at the same time is that in the southern hemisphere, it's been a very cold winter. And actually, cold extremes are generally increasing, not declining. And you know, the mortality from cold events is much greater than that from hot events. Droughts, again, no long-term trend over 1,000 years. The graph based on tree ring proxies shows that over the last 1,000 years, yes, there have been some very significant variations up and down as the climate varied, but no overall trend. And even right through the medieval warming and the Little Ice Age, which is quite extraordinary. But we do need to be prepared for droughts in terms of water supplies and so on. And there's nothing new about floods. The record I show there over since the 1700s, 300 years, is the longest rainfall record, I believe, for the island of Ireland, and based on very significant investigation. So yeah, there have been ups and downs, very wet periods, very dry periods. And we need to be prepared for those eventualities in terms of adaptation in our climate. And things do become exacerbated as population increases and so on. There's more faster runoff of water. So all of those are things that we do need to take care of. And the two pictures on the right, one from Denmark shows that the water levels at some times in the past are very high, and the marks on the wall in Germany do show that they have had many floods in the past too. Believe it or not, there is a declining trend in wildfires. The top left in Europe, the top right in the US, the global burnt areas, and in Australia. And they don't tell you all of that on the 9 o'clock news. The good story is the benefits of CO2 on photosynthesis. There's been a very significant greening of the plant over the last 40 years of about 15% as viewed from satellites. And that, is actually helping the world to feed the growing population of the world. So that's a positive of CO2, which is very seldom talked about. I come to conclusions. On climate science, yes, the IPCC models are evidently overheated and I suggest need reality checking. My empirical data points to only 0.5 to 0.8 further warming by 2100. And that would leave us in a position of, from pre-industrial, of 1.6 to 1.9 degrees above pre-industrial. So we actually can achieve, I believe, the Paris goals without any mitigation. And certainly there does not appear to be any crisis. Mitigation will have imperceptible impact, and few people realize that. And the CCC, the Climate Change Advisory Council, indicated only a few thousandths of a degree, even if we achieve the Irish 2030 targets. So mitigation is justified, yes, when there are economic efficiency and social gains, such as in retrofitting of houses. And a very important thing, the latest science is showing that methane has insignificant greenhouse gas effect. Yes, sea levels are rising, but by only 25 centimetres by 2100. Again, that does not appear to be a crisis. There's a stable situation in the Arctic, Greenland, Antarctic, glaciers and oceans. Many types of weather extremes are actually not unprecedented, but black swan events will occur as the planet warms and there's more and regular natural variability. So we need to be prepared for that in terms of adaptation. So adaptation is key, with mitigation only where it makes economic and social sense. On energy policy, people need to realise that reliable, affordable energy is essential to modern society. Renewables are great, but they're not dispatchable until we have commercial, large-scale energy storage. Meantime, we have to rely on conventional generation assisted by renewables until new technologies emerge after 2030. And that may be mini nuclear, it would be the best bet for the longer term future. Natural gas is absolutely key to our energy supply security, and we need an LNG facility for import for security. On agricultural policy, the latest climate science, the questions the proposed basis for cuts in Irish agriculture, particularly in view of our temperate climate, where we can actually produce very efficiently and need to help with the global food scarcity. On politics and communication, dare I say that politicians and media need a broader view on climate science. Realise that the immediate threat actually is energy security, not climate. And above all, media communications need to be more balanced. So we all want, and I really emphasise that, I too want a truly sustainable future, but let's be pragmatic about it. Finally, just some references. I've included 3 books there, if you're interested, well worth reading. And in the lower part, you have the YouTube links to all of the lectures that are on the ICSF website, which are by all the leading world's scientists. Thank you very much for your attention. I hope it's been informative and look forward to a lively discussion. Thank you.